Hello and welcome to this video. My name's David Thorne. This is the 9th video in my C programming playlist. And this video we're going to be talking about, or we're going to be introducing you to the char data type, or the character data type. So without any further ado, let's get started. As you can see, what I've done is I've listed a couple of characters here. And yes, okay, we have // which is a comment, which means it's code that doesn't get executed. We're going to move on to that later, but just think of it as this is just completely ignored code for the C programming language. Anyway, we have a capital D and we could have a lowercase d. Would be the same thing, but when it comes down to chars, they're two different things. Okay, we then have a percentage sign, we have a /, we have a 0, and then all the numbers all the way through to 9, not forgetting also then the dash, and we have uppercase A all the way through the alphabet through to the uppercase Z, and then the lowercase a to Z as well, and then literally the first row of all characters on my keyboard. It might be different on your keyboard, but this is my keyboard. Anyway, I think you get the picture. Basically, anything that comes in the ASCII table, any character that you can possibly have, is basically a char, a character. All right. Now, a char is not the same as some text, and we would call like this some text. So everything within inside of these quotes here, we're going to call some text, or we could call it a literal string. All right, a literal string. But for the time being, what we're going to care about here is we're more going to say that this is A, V, and then I, and then D, and then a space, and then I'm going to put a space for the space, and then T, H, O, R, N. Okay, this is what we're more going to look at. And what we can do, right, is we can say that my name is, and we're just going to skip over this for now. And we're just going to put some angle brackets here, and we're going to use the assignment operator once again. And here we're going to say David Thorne. All right. Now, you might get a little bit like, what's he doing right now? But that's okay. Whoops. Let's see. This is all okay, all right. All we're saying is that this here is saying it's a collection of characters, all right. So we've got the character 1, character 2, 3, 4, 5, 6, 7, 8, and so on. And within inside of these double quotes is a collection of characters. Now, if we want to talk about a single character, right, we can't use these double quotes because that's basically saying, hey, this is a literal string, right? And a character is not a literal string, right? A character is just a single character. So if we just say letter D, for example, we need to use this single quotes to say, hey, what's inside of this is a single character, and it actually needs to be a single character. And as you can see, it said int 68. So let's just, for the sake of interest, say letter A, and we'll just say A here, and see what Visual Studio says here about this. This is now letter 97, right? And this gets even more interesting for you, and I think this speaks for itself as such. So if this is 97, guess what B is going to be? You guessed it, it's 98. Okay, so as you can see, there is some form of like relationship between the letter A and 97. Or the ASCII table, you know, something's happening in the background here. Now, if you've ever seen the film The Martian, then with Matt Damon, where he's stuck on Mars, you'll see that they managed to talk to each other through the ASCII table, right? Through a program. Well, one of them's a programmer, and they talk through the ASCII table just using pure numbers, all right? And this is an easy way of understanding this. Computers don't understand letters; they only understand binary bits, all right, or basically high voltage, low voltage, and transistors. That's the only thing that they understand. So there needs to be some way of understanding. Let's just say BD as, oops, let's just understand, like BD is B for binary, and we had here then, we had in 97, I think it was. Let's just check. No, 60, 68. Okay, so the binary, or the integer definition, let's say, the integer definition of the uppercase D is 68. Well, this is really just like synonymous to char, okay? But char doesn't need all of that space, right? To store 68, we can pretty much store this in 8 bits, right? Because that's 68 is less than 255. 68 is less than 255, and if we do 1, 2, 3, 4, 5, 6, 7, 8, and we do 8 pieces, 8 bytes of memory here, and obviously at the moment this is indicating a 0. Now if we turned the first bit on, this would be the number 1. If we then turned the second bit on, this would be number 2, and we turn the third bit on, this would be 4, and if we turn the fourth bit on, this would be 8, 16, 32, 64, 128. And if we turned them all on, then we would get 255. So 68 is basically some way of showing 68 in binary, all right? And that would be, so 1, 2, 4, 8, 16, 30, 64. So 64 would be on, right? Now we need 4. So we still got 3. Yeah, now we need 4. So 1, 2, and 4. And this would be on. So we've got 64 plus 4 is equal to, let's remove this now, is equal to 68. So basically this is this in binary. And at the moment we're saying what it is in an integer, okay? Now a char doesn't need the full size. It just needs 255 characters, 250, like just needs 1 byte basically to show it. So this is synonymous to 1 byte or 8 bits, and that's the whole point of the ASCII table, all right? And like I said, this is an introduction to the char data type, and I just wanted to show you that when we're talking about int, we're talking normally about 4 bytes, all right? So this is essentially this in memory, right? It's got 32 bits or 4 bytes. Now a char just needs 8 bits, not bytes, 8 bits of data to store it to get 255, because that is the ASCII table. The ASCII table has all of the information on it. Now I'm not going to go over the ASCII table because this is down for you to look at, and if you don't know what the ASCII table is, then I really would recommend you looking at it. But if you're wanting to do C programming, then you should know what the ASCII table is already. Okay, so that's a top tip for you, ASCII table. Okay, so now we know that a char is basically 8 bits, or it is literally 8 bits of data, and that indicates a number that is a letter inside the ASCII table, or a symbol inside the ASCII table, or a digit inside the ASCII table, anything inside of it. All right, and a char, and then with the name, we're going to get over this later, with these with these square brackets, is saying, hey, I've got a collection of chars, all right, and that is what we call a literal string, all right. And so there we go. That's the introduction to the char data type. I'm going to go a lot more into this, all right, but I just wanted to show you in the beginning what a char is and what a char isn't, all right. Okay, thank you very much for watching, and I will see you in the next video. Thank you. Ciao, ciao, bye bye.